Hi, my name is Alec Turner. I'm doing this for Physics Lab I. The TA is Andy Svesco. This is the video analysis done on the shot of the basketball, and these are the graphs of which I get the speed of the basketball and the gravity experimental, which I refer to throughout the movie. Alright, so you guys have now just seen the basketball shot that I'm going to be breaking down. There are three things I wanted to break down about the shot, and that was the distance and speed of which the ball was shot at. And then I also want to talk about the angle of which it left his hand versus the angle it went in at the hoop. And finally, I kind of want to talk about how throughout the whole thing it conserved the energy of the moving basketball. So first, as you'll see here in Logger Pro, the speed is going in the X direction towards the basket is 5.4 meters per second. It actually kind of slowed down a little bit to about 4.9 towards the end, having about a 20% energy loss that way. But the Y left at 5.8 meters per second, and then from that I was able to get the gravity of about 9.93. So this is about 1%, within 1% of what it actually is, so I was pretty happy about that. I was able to calculate the distance was to be 5.3 meters, and it makes sense. The free throw, or the 3-point line is about 19 feet away, but when it left his hand, it was a little bit in front of it, which comes out to about 18 feet, so that was about right. And then this is how far it dropped from the top of the angle, which was 1.73 meters, and it goes down about 0.86 meters before it goes in the hoop, making it about 8.83 meters above from when he originally shot it, which when I added up from the point the ball was released and this came out to be about 3.05 meters, which is the height of the hoop, so that was good. And then another interesting part is I found the angle for both of these. It leaves the shooter's hand at about a 46-degree angle, and it goes in at about a 40-degree angle. In basketball, the higher the angle, the better, because it gives you a better chance of just going in. So 40 degrees is pretty high. It wasn't a knuckleball, it was kind of a nice arch into it. So that was nice. Then, last but not least on this, yeah, exactly, bud. We had the conservation of energy. So when it leaves his hand, it has, I just set it so that it would have 0 potential energy, even though it does because it's leaving at 7 feet. But I'm just ignoring that part and taking it out of the system. So we can look at the energy just after it leaves his hand, like through the whole arc. So when it leaves his hand, he gives it kinematic energy of 60.5 joules. And then, interestingly enough, when I did the calculation for when it was at top of the arc, it was also at 60.5 joules. So that was a good conservation of energy there. And then when it's even entering the basket, it's at 59.5 joules. So that's about a 1% loss of energy, probably from hitting the rim or air or the net or something. So really, all in all, the energy was conserved throughout the whole shot.